So thank you for joining the webinar for the Smart Cities contest that we have running on Hackster at the moment. As I was introduced, my name is Freiberg. I'm the Director of Ecosystem at the IOTA Foundation. What that means is I run a department which deals a lot with the developer community in IOTA. We deal with documentation, building developer tools, and also tutorials and things like that. And today I'll be talking through a number of different topics, which will go over what a distributed ledger is, what IOTA is itself, talking about how distributed ledgers can apply to different industries. Then we'll have a bit of a deep dive into some different IOTA examples. And then finally, we'll look at the way in which you might architect an application using IOTA to build something for the contest that we're running. So to start, we'll quickly go through the definition of what a distributed ledger is. So a distributed ledger by name is simply just that. It's distributed, which means that there is a network of different peers that are distributing information amongst themselves. And ledger being a database, usually the connotation is with financial information, but it can be any type of information that is shared amongst those peers. But what makes a distributed ledger special is the need for consensus. So in any distributed ledger technology, there will be a consensus mechanism which helps the network come to agreement on which information should be stored at any time. So through this, you kind of have a single source of truth where you can query the distributed ledger and have an understanding that everybody else has the same idea that you do, or is getting the same information that you have. So what, So what benefit does this distributed consensus provide? So when you have a ledger or a distributed ledger, usually they're append only. So that means that you can only add new records to the end of a ledger. What this means is that you have an immutable record of what's happened. So if you publish information to the network and everybody agrees that it should store that information, then when you look at it in a day or in 5 days or a year, you can know that you can find that exact same information, and it's very hard to change those records. And where this becomes quite useful is that you can start to think about having distributed financial records. And so a lot of the different use cases that you could think of, like things like Bitcoin and other type of cryptocurrencies, are enabled by a distributed ledger because of that immutable and verifiable record, but also that single source of truth, knowing who owns what and where the state of the ledger is. So this gives you a potent combination, having the ability to have distributed consensus and be able to append new information to that ledger. Lets you do things like have something like programmable money, where you're able to start to create applications that transfer money between each other, whether that be from person to person, from machine to machine, or from person to machine. So what is IOTA and how does it relate to a distributed ledger? So IOTA itself is a distributed ledger, but it has a different structure to the more common networks that run on things like blockchain. So in most common distributed ledgers, they use a blockchain, which is just that. It is a chain of linked blocks that are appended onto the end of each appended onto the end of the distributed ledger. Whereas in IOTA, what we have is something we call the Tangle. So this is a directed acyclic graph that individual transactions are added onto the end of the network, and they reference and approve previous transactions. So why did we decide to go and create something completely different rather than use the same old architecture for the distributed ledger that we have? So when the IOTA co-founders came together back in 2015, they wanted to create a network which would enable the vision of something we call the machine economy. So we'll talk about a little bit about that later. But in the machine economy, there are billions of devices that are able to interact with each other, offer services, and transact at really high speed. So when you have a network that needs to be able to handle that, they were looking around for ways to also send transactions. And what they saw is that there were limitations in the supply and demand of a blockchain. So in blockchains, when you send a transaction, it has to be put into the next block. And so these blocks have a specific size, which might be 1 megabyte or 100 megabytes. And you fill them up with transactions, and then they're appended to the end of the chain. And so this happens at a frequency of, say, 10 minutes or 5 minutes or something like that. But once you've filled up those blocks, you can't issue any more transactions on the network. And so what you have is a classic bottleneck, where if you have more demand than there is supply, then some transactions will miss out on being published. And a way that they've solved this problem is through prioritizing transactions. So if you want to get your transaction in the next block at a high peak period, you have to put out a fee for somebody who's going to validate the transaction to put your transaction in the next block. And so this leads to sometimes expensive fees and unpredictable fees on the network. But in IOTA, there's a different approach. So instead of having individual blocks that have thousands of transactions within them, we have individual transactions being added onto the main ledger that we call the Tangle. So in this diagram here, each box represents a transaction, and each line represents an approval. So when you issue a transaction on the network, you have to approve 2 previous transactions, which will then, which is required to get your transactions added to the network. And so as people continue to publish transactions, they might pick up your transaction, and by doing that, they actually approve your transaction. So they make sure that your transaction doesn't create any more tokens and doesn't create any new tokens. And if that's all okay, then the transactions will be accepted by the network. So as I mentioned, individuals publish their own transactions. So what this means is that you have one type of user on the network. So instead of other networks where you need to have miners as well as the users of the network, in IOTA you only have one user type. And so if you're publishing and validating the transactions yourself by picking those transactions that you approve, then you have no fees to pay any miners. So with that, you're able to send zero fee transactions. So if I wanted to send a cent from my IOTA wallet to another IOTA wallet, you would be able to receive that exact amount. So there's no requirement for you to pay anyone a fee, which means that you can have these very, very small payments occur. And you can have an understanding of, if I'm going to ask for 3 cents for my service, then I'm going to receive that exact amount. So as I mentioned before, any distributed ledger needs a consensus mechanism. And so we have a similar approach where in a blockchain, you have the longest chain, which is the truest history. So that means that as more and more blocks are added onto the network, the longest chain of that is the winner, and all other forks or anything else will be left behind. Similarly, in IOTA, we have the idea of the heaviest tangle, so the heaviest branch of transactions here that are valid will continue to be the correct length in the network. And if there are any transactions that, conflict, then they won't be built upon and they will kind of die off. And so this is a visualization of the network that we have. So it looks a little bit more messy and a bit more complex than the diagrams I showed you earlier. But this is a GIF of the mainnet that was a couple of months ago. So this is what the live IOTA transactions kind of look like coming in. Each individual transaction building upon the latest one to form a kind of snake-looking thing, which we call the Tangle. And if you go to the link down there, you'll actually be able to see the live network running and transactions being added to it. So while we have this technology, which is able to transfer tokens from one user to another, and also send transactions with zero value with data inside of it, how can you apply this and make it useful? So the IOTA protocol has a number of different features given its unique design. So one is that it's highly scalable when you don't have to wait for that bottleneck, for that supply and demand gap, and you can just publish transactions individually to the end of the network. You have something that's a little bit more scalable than other solutions. Also, because you only have one user class, you don't need to pay any fees to anyone. So you can do zero fee transactions, which can carry data, but you can also send transactions that carry value as well. And with those, you don't have to pay any fees to anyone. We also have a low resource requirement for these transactions. So small devices are able to sign and send these transactions quite easily. And given that we can send data through the network and the ledger is append only, you can know that when you query it back, that information will be changed. And finally, we have quantum resistant signatures, which will help in the future if quantum computing becomes a problem. So with a protocol with all of these features, what can IOTA offer? So the first one we kind of talked about was having that immutability. And so if you wanted to have a notarized document and you wanted to make sure that that document was signed on a specific date, you could publish a record of that to our network, and you'd be able to fetch it back later and know that that information hadn't been changed amongst the nodes of the network. So you get this immutable data record. And so this could be anything from sensor information, audit trails from vehicles or anything like that. And this can be used for a various number of applications. So once you have the immutable data being stored, you can start to think about adding that in with value transfer. So if you have a network that can do both data and value transfer, so sending value, which could be 5 cents or 10 cents or $1,000 through the network without any fees, and you can also send data through that, you can start to have devices and people communicating in ways that can create new business models. So thinking about the way in which you might decentralize EV charging, which is something that we'll talk about later, and also creating new types of business models like data marketplaces. So IOTA can innovate in a number of different areas. And so at the IOTA Foundation, we have an interest in a large number of different areas. So the IOTA Foundation, just quickly, is a non-for-profit that's based in Berlin. We have about 90 employees globally. Some of them are developers, some of them are researchers, and some of them are working on these individual industries to apply the technology and make sure that it becomes a standard in the future. So IOTA can be applied to any number of these, thinking about smart mobility. So what happens if you give a car its own wallet and is able to start to pay for services and also offer services? Additionally, there's been some work on smart energy, looking at the way in which you might balance a power grid using incentives, but also transferring information about that. You can think about e-health when you look at patient records, also providing consent and access to different types of information. Looking at digitizing the supply chain, and also looking at the future of the way in which factories interact and industry runs. So while we can individually affect those different industries with this new technology, these industries themselves don't operate in a vacuum. We all live on planet Earth, and these industries interact with each other. So what will happen is, when you start to integrate these technologies into one domain, you start to get value created by the intersection between those. So you can think of the smart city as the prime example of that, where you have mobility, energy, buildings, districts, these things coming together and creating value for everyone that lives within them and improving efficiencies there. And so I mentioned this term earlier, the machine economy. So this is something that we want to create. We want to be able to, we want to enable machines to have the ability to offer services and to pay for things in a seamless way using value and data. So the machines might want to buy energy, buy data, buy mobility, and they're able to offer and pay for that using the same network. So while that's all a little bit abstract, we can zoom a little bit closer into something that's a bit more tangible. So, I mean, in this diagram here, we can look at a number of different areas. So we have a vehicle here that might be offering ride-sharing services directly to its own wallet, not to the user who owns it. It also might, in the course of driving around a city in a day, might also pay for a toll directly from its own wallet. And then once it's finished driving around all day, it might go and start charging itself and pay for that charging using its internal wallet. Now, when you think about how those chargers are able to get their energy, you can start to think about energy districts within neighborhoods or cities. So you might have rooftop solar installations that provide certificates of the clean energy that they produce using the ledger to have that audit trail. Then once that energy is generated, it needs to go somewhere. So how the grid within a neighborhood might distribute energy by selling and purchasing energy for those within their immediate vicinity that needs to use it. And then finally, you can think about grid balancing. So when there's a surplus of energy in one area and a deficit in another, you can transfer energy through that and pay for that across different regions. And to continue, you can think about how you might monitor buildings, so you can maintain or at least have a copy of their energy ratings and things like that. You can provide access control and do logging of that type of stuff on the immutable ledger. And then moving out to more district type services, thinking of real-time data from street labs, from parks, things like that, to be able to provide information for the individuals living within it, but also the services or the service providers that are offering something. So what I'm going to do is I'm just going to play 2 videos that introduce the use cases a little bit more in depth in specific areas. So this is from the Dutch grid operator, from the consortium of Dutch grid operators called LNL, and they're looking at how IOTA can be applied into smart charging.
In tomorrow's world, we'll all drive electric cars. And by using solar panels and windmills, we'll generate our own renewable energy. With smart charging, we'll make sure we use 100% of what we generate. This means that all kinds of devices have to start communicating with each other, and there'll be a need to make or receive payments for their services. That may sound complicated, but in practice, people won't even notice the devices are at work. Let's say you work from home today. Your electric car is parked outside and is charged by the overcapacity from the solar panels on the nearby school. In the evening, the energy stored in your car will now power the lights in your house. And together with other nearby cars, you might even be providing the power for a concert in the local park. Throughout the night, windmills located just outside the city will refill the car batteries. So in the morning, you leave for work fully charged on renewable energy. To successfully automate this whole process, both data and value transactions have to be calculated for every exchange between these devices. In the future, these will increase exponentially. The old approach of registering every electricity exchange centrally and then paying through the bank afterwards is not particularly appropriate for these kinds of microtransactions. Luckily, there's a new kid on the block: cryptocurrencies. These are way more suitable thanks to the underlying distributed ledger technology, or more simply, DLT. It is secure, transparent, and peer-to-peer, and supports both data and value transactions. The best-known DLT application is the Bitcoin, but because of limitations in its technology, it's not really suitable either. But hang on, recently, better alternatives have become available. One of them, IOTA, makes use of the Tangle, a new kind of technology, which is ideal for these microtransactions. It is fast and costs close to nothing because the users validate all the transactions themselves. It's an ideal, decentralized approach. To explore this possibility, we've built an IOTA charging station prototype, where you can use IOTA to pay and charge. No need for a card or subscription. When connecting cars, solar panels and windmills to the IOTA network, all these devices will be able to sort out the transactions and their related payments themselves. It's easy, safe and reliable. Exactly what we need to live in tomorrow's smart charging world. Join us in further exploring these exciting opportunities. Let's co-create.
ELAD NL.
Okay. Cool. So that there was a video just describing the various applications of IOTA within electric mobility, but also thinking about how it can affect the grids as well. I'm also going to play another example on how IOTA could impact the future of the global supply chain. and then we'll continue with the presentation after that.
A cup of coffee to get the day started right is a must for many. But do you ever wonder how the coffee made it all the way to your table? And even if you think you know, how can you be sure it's true? Supply chains are complex systems with many actors involved. At every step in the supply chain, data must be verified before exchange of custody. The ever-growing flow of goods puts our current logistical structure under a lot of pressure. Critical documents go missing, cargo gets stuck at customs, and agricultural goods deteriorate while awaiting border clearances. $4 trillion are lost each year. That is more than the entire German GDP going right down the drain. What if we told you all of this is about to change? Introducing IOTA, the world's first open-source distributed ledger built to power the Internet of Things. By implementing the Tangle, the data structure behind IOTA, a single version of the truth is enabled by logging the entire supply chain onto a tamper-proof distributed ledger. This allows all involved parties to review the what, where, and when of the coffee bean's journey. Smart devices constantly communicate with each other to record and exchange critical logistical data. Effortlessly monitor essential activities, from air temperature to date stamps and GPS locations of shipments on the go. Many companies are already attempting to prove the sustainability and ethics of their products. By utilizing the Tangle, this ambition can finally become reality. Imagine a future that's transparent and incorruptible, where each transaction is verified, recorded, and easily accessible in a tamper-proof ledger. A future where the supply chain is faster, smarter, and secure. Join us in creating that future.
Great. So I hope that example also illustrated another approach or another way in which IOTA can be applied to an industry. Continuing on in this vein of talking about different use cases, one of the interesting use cases that's coming out of the mobility area is applying an IOTA wallet into a vehicle. And just recently, as a couple of days ago, there's been a new wallet announced by a company in Germany, which would allow for vehicles to be able to talk to smart chargers and any type of point of sale and be able to purchase goods and services from those. So this is an interesting way of augmenting the already existing machines to be able to make them smarter and more efficient and operate by themselves. Another thing that's quite close to us as well is looking at a little bit more about sustainability. So the IOTA Foundation has joined City Exchange, which is a Horizon 2020 initiative, which looks at positive energy districts. So looking at being able to intelligently manage grids locally through renewable energies and also sharing energy within the grid in the neighborhood. And so this was kicked off recently and it's focused on building out a framework and tools to enable a common energy market among a community. And so they're going to come out with a number of different demonstrations which show how technologies can be used to create these positive energy districts that will ultimately have a positive change on the environment and also the people living within them. And then the final one I'll just quickly talk about is digital identity. So IOTA can also be used to have records of individuals' identity and also have audit trails to enable access history and things like that. So there's a startup that's called IAMPASS. They built a scanning terminal which uses the IOTA ledger in the background to be able to record the history of access, but also provide access control information on the Tangle. So you can have a single identity using this scanner, which uses a palm-vein sensor, and you can have a history of all of your activities and your access rights, and be able to use that in a kind of secure and also in a private way. So I talked about two use cases earlier. We also watched a video on EV charging. I'm going to dive a little bit deeper into the EV charging case and show an example from IOTA Tangle about the charger that they built themselves, and talk a little bit about that and the open source nature of what they were doing. And then I'll also talk a little bit about the data marketplace example that the IOTA Foundation itself built. So to start off, we'll talk about the marketplace. So in the future, there'll be a lot more devices than there currently are, and some numbers are pointing at there being 75 billion devices by the year 2025, which is an outrageous number of devices which are either going to be sensing something, publishing information, or doing simple tasks like access control and things like that. But what we'll have is all of this data being created, and all of these devices connected to the internet, but they'll all be siloed off. So individuals will own these devices, and they'll create a wealth of information, but that'll only be accessible to them. What could be done with that information could be any number of things. So if you have devices throughout a city, you might have the ability to start more accurately mapping weather patterns using hyperlocal information, or you might have environmental information about air quality or anything like that. But that information isn't really going to reach anyone if you're just using it personally. So what we want to do with IOTA is start to break those silos open and allow for people to either monetize that information or share it freely, and have value be created on that information. And so this is something that we're doing with the data marketplace. So the data marketplace is a proof of concept application which is currently running, which we're looking to build a type of circular economy with low-cost single-purpose devices. So these devices are able to take in information, take in sensor information, publish that information out to the Tangle, and then be able to sell that to another device that needs it and purchase information back themselves. So the data marketplace is a proof of concept that's live on the internet right now. And you can go and check it out yourself, but I'll just quickly explain how it works. So as I said, the device itself has all the sensors on board. It's able to capture that information. And so this might be something that you'd want to look at for your own contest submission. So it captures the information, then encrypts that information and publishes it to the IOTA Tangle. And then once that information is up on the network, people can ask the device, or devices can ask the device, for access to that information by providing the decryption key. And obviously, if the device doesn't want to do that for free, it can charge people tokens, charge people value to be able to provide that information back. And so this is the basic idea behind the data marketplace. And so you can go and have a look at it now if you'd like, and you'll be able to go in, have a look at the different sensors available and purchase information back from them. And so this really illustrates a small example of how you might start to increase the velocity of information within a city, and start to utilize that for benefit, whether that be for creating value for the person who owns the device and is selling that information, but also by enabling things that weren't possible before. Because the more information that you have, the more accurate your inferences are from that data. And the next one that I'll talk about, which we watched the video on, is the decentralized EV charger. So this here is a small little Tesla, and that Tesla has off-the-shelf equipment that you would find in a normal vehicle, so all ISO rated, and the charger that's physically there as well, it has the same type of equipment in there. And this charging example is able to accept tokens for electricity and be able to charge vehicles without any help from anything else apart from the IOTA network. So to give you a bit of a context about why this might be a useful scenario, we'll talk about the way current EV charging infrastructure works. So if you own an EV charger, you kind of know some of these challenges, but if not, I'll just walk through them just to show you the kind of fragmentation of the industry. So within a city or within a country, you might have multiple service providers. So if you want to go charge your vehicle at a specific green or a yellow or a blue charging point, each one of these are branded and they usually have a different RFID card, which means that you would need to be signed up with multiple charge point operators. So you might have 4 different apps on your phone or 3 different cards in your wallet. And each time you need to do that, you need to sign up, load money into your wallet using conventional methods. And then whenever you get to the charger, you have to tap your card to be able to make it work. Thinking a little bit bigger than just within a single region, if you look at charging across borders, so you need to be able to, if you want to drive your car from one country to another and be able to start charging, you again need to sign up to different providers, but also, how does money get transferred around, and those types of problems also exist. Then you also have a lack of transparency. So, how do you know that the price you're getting is the best price if you're, within the vicinity of the closest charge point operator? How do you know that the charge points themselves are actually available or not? And usually you have to sign up. When you sign up to these companies, you have to have contracts that you sign and things like that. So in a standard charge point system, you'll have multiple different providers that are talking to each other. So they'll usually be sharing information or energy or anything like that. And in terms of payments, you'll have to have a clearinghouse that exchanges money between these different organizations. This gets a little bit more complex when you start to think about having multiple clearinghouses. This might be within a country or within a region. And the picture is quite convoluted, and things take a lot of time to finally settle. So the Dutch grid operators, LNL, looked at ways in which they might use new technologies like distributed ledgers to improve the infrastructure, or to at least augment it in a way that is more efficient or creates benefits. So they, from what they saw, they could use distributed ledgers for direct payments. So there's no need to set up, an RFID card that's mailed to you. You don't need to set up subscription. You don't need to sign contracts between individuals, anything like that. You can just use the network to do payments and also data transfer. Secondly, you're able to do direct information sharing. So instead of having to have a large back end where you have multiple servers, multiple kind of connections in different networks, to have data shared from the individual's phone to the charge point and all the way back around, you'd be able to share that information through one mechanism. So say IOTA, you'd be able to send the data and the value through the same network, which would remove a lot of the need for a large back end. You also have transparency. So given that IOTA is a permissionless or a public ledger, anyone can interact with it and anyone can join it. So you don't really have the need for an organization with a specific reputation in being transparent or providing correct information. You can just use the immutable ledger to know that the history that you have hasn't been changed or anything like that. And it also allows for a decentralized way of delivering and distributing energy. So you can start to have these charging stations paying and distributing energy amongst themselves in a smarter way. So when they were looking at the options, they saw IOTA had a number of advantages. So in terms of the advantages I talked about earlier, we have no mining, so it can be seen to be more sustainable. We don't have fees, which allows you to share data. Because on other networks, if you pay a fee, you might have to pay 20 cents or something to publish a small piece of information that says the charging station has changed from in use to ready to be charging. There's no blocks, so we have a faster transaction speed, and also we have a more scalable approach. So this is the initial version of their charger. So they physically implemented a charger that had off-the-shelf components. Everything that they did was all open source. This means that it's all easy to clone. And because they're using IOTA, there was no need for a back office, so no need for the servers that maintain and run the chargers themselves. Each one of these devices is standalone with a connection to the Tangle. They're able to listen for information and also receive payments and pay for things as well. So the charger itself was able to broadcast to the Tangle, so it tells the user where it was, what its payment addresses are, the price of the electricity at that time, as well as storing the charging sessions. So if somebody wants to see how much they've spent on charging, they can go back and look at the transactions and see what has actually happened in their history, and be able to receive that back. Also, instead of having to use, say a Visa or a MasterCard or bank payments, they're able to directly receive payments to the charger itself. So there's no need for any overhead infrastructure. The vehicle that wants to be charging will send tokens to the correct address, and the charge point will receive that directly. And then finally, there's a direct communication channel with the customer, because they're able to just send the data to the correct address, and the device can read that back. So this is the view of what you could actually do with the charger. So they had a small application with a wallet that you could pay a couple of cents for a kilowatt of electricity, and the charger would be able to start charging once it received those tokens. And it's relatively simple the way in which it worked, in terms of being able to send information to the network as well as receiving payments. The version 2 that they built was quite cool as well, in the sense that they had a direct connection between the EV charger and the vehicle. So they had communication running over Ethernet in the cable, and they were able to negotiate payments and then settle those payments up on the Tangle, as well as publish an audit trail to that as well. All of this is, again, based on standard hardware, which is really good for adoption, being able to use this to be able to integrate into a number of different services and build upon it as well. And finally, it allows for additional use cases. So not only is this all a charging station, but also if you can think about reversing the flow. So your vehicle is a large battery on wheels, basically. And at times when there's peak demand, whether that be just after work or something like that, devices will be able to, or sorry, vehicles will be able to send electricity back to the charger, and the charger will be able to pay the vehicle for that and balance the grid out a little bit better. So as I said, the interaction was quite simple. The vehicle just asks the charger for electricity. The charger responds with that. The vehicle then pays to the correct address, however many tokens is requested, and then the electricity is sent through the cable. So all of the negotiation, the payment history, the payments and the history are handled by one network, which is a lot simpler than what was previously available. And so this was the final result, a small little EV car that you could actually drive around if you were small enough, that allowed for charging through IOTA. And so instead of having a number of different operators with connections between various backends, you have a vehicle talking directly to the charger and then paying for and publishing history to the Tangle that can then be fetched back later. And then you can think about it on the other side as well, where you have a grid talking to the charger and paying for or selling electricity through that manner as well. So, when you have a vehicle that has a wallet, in this case, using the charging example, you can think of extending it. So you can, start publishing those charging sessions. You can have a digital twin of the car. So you can have odometer readings, manual history of repairs or anything like that. So that you can see it when, if you want to resell the car or if insurance wants to have a look at the history of the vehicle. You can start to think about, sharing economy. So an EV sharing its services, sharing its mobility service for payment, and then thinking about, parking or charging or anything like that. So I've just gone through a number of different applications of IOTA. So how you might apply it to EV and mobility, looking at supply chains, looking at and something that wasn't quite possible before in the data marketplace. And then we had a bit of a deep dive into some of the hardware, of building and charging stations and stuff like that. So this is a little bit more relevant for those that are participating in the contest, making sure that you have an understanding of the way in which you design an application for IOTA. So IOTA itself has a number of different networks. So anyone can go and create their own private network to test on them. In private, but I would suggest that you would use one of the networks that is available right now. So in IOTA, there's the mainnet where you have the kind of the distributed ledger that everyone uses, and this has value and data being transferred through it, and it's been running since about 2016. And because IOTA doesn't have fees, you can use this without any fees. But what I'd suggest is it's better to start with what we call the DevNet. And so links to all of this information and links to actually getting started with the mainnet or the DevNet or anything like that. That's all on the contest page if you want to go have a look at it. But the DevNet is a place where you can safely interact and build proof of concepts. And what's also good is that we have something called a faucet, which allows you to receive tokens without having to purchase them through an exchange or something like that, or use any real money in that case. So with this, you can connect to the network, you can start sending transactions, you can listen for transactions. You can also receive tokens and start sending and receiving tokens for any of the example use cases that you might want to build. The next best resource is also the documentation. So this is also linked on the contest page, but it's docs.iota.org. And this has been recently redone. We have a lot more information about the basics of IOTA if you want to grasp or get your head around what the basics are in a lot more depth than what I talked about today, because I'm sure there's a lot of questions. We also have the list of the different client libraries we have, the different applications, whether that be IRI or ERI, which is a node software. So if you want to run your own node, you can use that. We also have stuff on Hub, which is our token management system, as well as various other applications. But for most that want to get started and start playing with IOTA, you jump straight to the client library section and download the language that you're most comfortable with. We have a number of different officially supported languages, the main ones being JavaScript, Java, and I think it's C. But we also have a number of community contributed libraries. We have Python, we have Go, we have C#, .NET library, and there's a few other ones that are out there in various states. So I'd suggest going there and having a look and getting started with the examples that are in those repos. One good resource though, to give you an understanding of how to simply progress with IOTA, there's a little workshop that I put together on the community GitHub. And that basically walks you through from the hello world of IOTA all the way through to starting to listen on a live feed for transactions that are relevant to you and starting to act on those things. So if you go in there, there's about 10 or so different examples that you can go from sending a hello message all the way through to managing a wallet and stuff like that. So getting a little bit deeper into how you might think about creating an application with IOTA. So data is obviously the lifeblood of any application. So before you start building anything, you need to make sure that what you're building is structured correctly so that you're able to avoid the pitfalls before you even get started. So in IOTA, we have a specific kind of structure for the information that is sent to the network. So we have an address where you will send the data or the value that you want to send in that transaction. We have a message which has a field which you can either fill with the signature, so the cryptographic signature of the wallet that or the address that you're sending from, or if you're not sending any value, you can send a message in that. And so these fields, they use the word tryte here, but they can carry about 1 kilobyte of ASCII data that you can use for whatever you want. So you can store JSON in there, or you can store whatever format, and you can publish that information, look at, watch that address and retrieve that information, and then use that in various ways in your application. And we also have a tag in there as well, which is a field you can manipulate and search for those when you want to. So in terms of how you retrieve the information, there's a simple call called find transactions on the node software, and the various clients have different ways of fetching, but they all have that as a basic functionality. And you can fetch various fields. You can search various fields on the network. So once you publish some information, you can fetch that back either as a bundle, so a group of transactions, an address, which is like an entry in a database, a table in a database, you can fetch that back, or in tags, which is another way of kind of linking to that information. So I'm talking about various different concepts that might be a bit abstract. So an address, you can think about it as just as a table in a database. So each transaction that is sent to that address is a row that has been added to it. When you're building a simple data application that is sending and receiving information on the network without any tokens, there's no need to know the private key or to control the private key of that address. So you can just use it as you normally would a database. And you can choose whichever address that you want. So, if you have a specific way of, assigning an address to an individual device that you might be using or a service, you can use those to track transactions which are relevant to a specific action or device. And as this is a distributed ledger, these kind of tables in the database are append only. So each time you publish to it, if you fetch it back, you'll get the list of every single transaction that has been at that address, plus the one you just published. Next is a bundle. With every transaction, you also get this unique hash from that's included in the transaction, which is called the bundle hash. And so a bundle can contain a single transaction, or it can contain multiple transactions. And you can kind of think about it like a multi-write operation. So you can update multiple addresses at once and add multiple items to those addresses. So with that, you can send commands or send messages to various different addresses on the network that things might be listening to. And if you wanted to fetch them back, you can ask for that whole group of transactions, and you can use them for whichever way you like in your application. And finally, we have the tag, which is just a 27-character field that is chosen by the client. It's not required to have one, but you can use that to tag transactions with a similar purpose or a similar type that you might want to use in the application. And finally, we'll talk about the kind of levels of decentralizations in applications. We're just going to go over decentralized and semi-decentralized applications for this. So in terms of decentralized applications, there's a definition that we can look at from Wikipedia, which is the code for decentralized applications are usually open source and managed autonomously. The records of the data are stored using a distributed ledger, providing access in a trustless manner, so you can ask anyone on the network for that information, you'll get it. And because of that, there's resilience built into it. And usually there are tokens associated with it, whether that is sending or receiving them for payments. So an example of something like that would be a voting application. And so this gives you, a decentralized voting application gives you censorship resistance. So if you had an application that you wanted to poll people on or something like that, it'd be very hard to take down if it's on a distributed ledger like IOTA, in the sense that once it's in the ledger, if you know where to look, you can retrieve that information. And because the network is distributed, it's quite resilient to downtime, given that there are thousands of different nodes that are all receiving that information and serving it back to people. But the problem that you have with any decentralized application is that you have, anyone can access it, which means that anyone can send information to it or manipulate it in different ways, and you have to be very smart in the way in which you look at the data structures that you create, the application logic that you have, so that it doesn't get manipulated. And also, given that it is decentralized, it has a performance deficit. So you have to run within you have to use the IOTA network, which is optimized for being a distributed ledger, not for being a high-speed data processing network or something like that. So if you choose to go for a decentralized approach, you have to make sure you understand the difficulties associated with it. The last thing that I want to talk about is the semi-decentralized application, which is the most common type of application and what I expect most people to build in this contest, or at least submit an idea around. And so the records of the data are going to be stored using the network, and they provide that trustless interaction, given that there is, given that anyone can access it and be able to verify that information is true. But it doesn't. There still requires a web server to serve the front end of the application, or there still requires there to be a server which might hold different information, but you use the distributed ledger to hold the hashes of that information, so you can verify it at a later date. And so with these are usually a little bit more closed source, and like the data marketplace is a good example of this. This is a semi-decentralized application using a web server to serve that information, but then for the immutable information from the sensors, that's published through the main network. And yeah, so you have the ability to have these hybrid applications that have the benefits of the standard technologies that we use today, but also you have the distributed ledger technology that can then augment that by providing value transfer, immutable audit trails, things like that. But as you use these different technologies, you have different performance deficits using a distributed ledger, but also advantages when you use other technologies with it. And so just finally, I want to point you back to the Hackster contest page, which has a whole bunch of different resources for development. So we have examples of different applications and the code that's associated with them. We have a whole bunch of tutorials that have been live streamed on Twitch talking about the different technologies. We have blueprints for different use cases. We have links to the documentation. We have a whole bunch of other stuff. So I think I'm going to end it there, and we can take some quick questions, as I think I've run over just a little bit.
Okay, we have time for a few questions. We have 3 questions so far, and feel free to use the Q&A if you see it at the bottom to ask questions. Okay, all right, so Louis, the first question is, will the slides and recordings be made available for later viewing? I can answer that one. That's yes, we'll definitely have the recording available. Louis, you can send me your slides and I can share it.
Yeah, no problem.
Perfect, and we'll send some links and email this, all the links we talked about here to you guys. Okay. So next one from Joy DeBroy. If a card is stolen, we can block it. But what about when a machine is stolen, like a car, and the stolen card can still be charged because car and charger know nothing about stealing?
Right. That's a really, really good question, actually. So if going back to the credit card example, well, if you think about a credit card itself, if somebody steals a credit card and it's only enabled through PIN, it's going to be very hard for someone to be able to use that as a payment method, because if they don't have the keys to be able to open the chip that's inside it, then they're not going to be able to use it for any payments. So if you think about a physical device that might be a charging station, sure, you can steal it, but there may be ways in which you can stop the extraction of the private keys, which you also have in your credit card, that would stop people from using it at any time in the future. So, and there's work in terms of hardening hardware for distributed ledgers. So there's some work being done, in terms of hardware wallets, which, for example, this is a hardware wallet. It's very hard to get the keys off this. Even if it's stolen from me, I need to have both the device itself, which is something that you have, as well as something that you know, which is the passcode to open it. So usually in these examples, if somebody opens the case of one of these devices or something like that, they're not going to be able to tamper with it because it will lock itself down.
Okay, thanks. So then the next one, Sanyade Adekoya, he asks if you need a license to operate an IOTA charger. I'm not sure what he means by this.
I would imagine if you run a charging point anywhere in the world, you probably need a license for that. But IOTA itself doesn't have, doesn't sell IOTA chargers or anything like that. We purely provide the software for people to build upon. So we're an open source organization. Everything that we build is free to use by anyone, commercially and also individually. So if you want to build anything with it, whether that be an IOTA charger or something which is like a vending machine or anything like that, you can build and you can have a business on that.
Okay, Michael Mitchell says, how are unique object addresses obtained within a Tangle?
Okay, so within the Tangle, there's kind of an infinite number of addresses that you can use. And so the starting point for any address that has value on it is something called a seed. So you can think about this as your private key, something your secret. And from this, you generate addresses that you can control. And what I mean by control is, you can move funds from that address. So if you think about it like a bank account, you have your own bank account number. And because you have the access to the bank, you're able to authorize transactions and things like that. So because you have this secret, you can generate addresses. And from those addresses, you can generate transactions. But if you want to just use an address for data, what you can do is you can just generate a random address. So you can just type in whatever characters that you want, and you can use that as the address rather than having to use this complex method of generating them via a wallet or using your secret.
Okay, so Stephen Smith asks, can data be sent from a sensor to the Tangle? Can data sent from a sensor to the Tangle be cryptographically encrypted, or is the raw data discoverable by any participants?
Yeah, so that's a really good question. It can be. So any data that you publish to the network is going to be public, though. So if you look at, if I sent a message to the Tangle in plain text, which said, hello world, or had my bank account information, or had my, password manager information in there, that wouldn't be a very good idea. But what you could do is you could encrypt it using other means. So you send the transaction, but within it, you've got a payload that you've encrypted using standard cryptography libraries, or within IOTA, we have something called a masked messaging kind of protocol. Masked authenticated messaging, MAM. And with that, you can send strings of information that are linked from the first transaction all the way through to the latest transaction. And those can be encrypted, or those can be public that you can have a look at. And if that's environmental data, you might want that to be public. But if it's information you want to sell, you might want to encrypt that and then sell the keys to someone else so that they can access it. With information that you publish to the network, because it's immutable and because it's always going to be there, you really wouldn't want to publish personal information. So in Europe, GDPR is a really common, is legislation that relates to the privacy of an individual. And a part of that is being able to remove the data. So if you're a business that's using the Tangle and you publish personal information to the network, you're going to have a bad time trying to remove it because you can't. So just be careful of that when you're starting to publish information to the network.
Another one from Sanyade Adekoya, he asks, is IOTA only available for city? What about holidays, farming, sailing, and traveling?
I'd hope you could do all of those with IOTA. You just have to build the application that enables that. So I'd like to see what you come up with.
Okay, Stephen Smith asks, to what extent is the IOTA Foundation available to support individuals and companies in implementing applications for IOTA?
So the IOTA Foundation, as I said, is a non-for-profit based in Berlin. So the foundation itself is funded by donations from the community that were given just after the initial tokens were generated. In terms of supporting individuals within the community, we have something called the Ecosystem Development Fund. So this is a group of tokens that were again donated to fund projects that would support the ecosystem. And what that means is this could be open source tools that build upon the basic layer that IOTA is. This can be something like new software that allows for data to be geolocated, or a library that would enable people to better manage their wallets, all the way to people wanting to build new client libraries and things like that. So if you do have something that you want to build that is open source and will help the ecosystem, you can go through that channel. But if you're looking for something that's more related to starting your own business and you're looking for seed funding, at the moment we don't have a clear pathway for that.
Ali Smith asks, how much of the Tangle does a node need to store in order to attach/generate transactions?
I think there is definitely a minimum amount. I'm not sure of the exact amount, but you can get it down to something like, I think, less than a gig. Most distributed ledger applications, something like, I think Bitcoin is 500 gigabytes. The whole of the IOTA history is something like 260. But nodes running today on the network, because we have this thing called local snapshotting, which means you can prune the history of the network down to, like, I think 100 megabytes, just the list of all of the value addresses. You're able to have lower resource devices be able to act as nodes within the network. They don't have to store that whole ledger to be able to interact with it. So not that much in comparison to other networks.
Okay, Diego Stuckey asks, what if the person buying the key from my data then shares it with others?
I mean, that's the same issue that any system will have. Once somebody has the data, given that it's it's data, it can be replicated quite easily on any type of system. So the value in the data might be the fact that it's real time. With something like the master authenticated messaging, what you can do is you can change the access key every message, or every hour, or every year maybe. And so if you provide a service, which might be a stream of information about a local area, or environmental information, people are paying for the access to the latest information, because if somebody has accessed it previously, then they may be just copying yours and selling it again.
And Lewis, it's 10 o'clock, but if you're cool with it, we can do a couple more questions, if that's fine with you.
Sure.
Okay. All right, great. So Michael Mitchell asks, are there any certifications for developers?
So the IOTA Foundation at the moment is kind of feeling out how the certification process will work for developers, but we encourage people to have a look at the resources that we have available and skill up yourself. The community is really vibrant in the sense that you can come in and ask questions and be helped out on your projects. That's what I did initially. I joined the foundation 2 years ago just by joining a chat room and kind of started building stuff and got into it that way. But in terms of developer certifications, we will be looking to have something available in the next few months that will provide a stamped IOTA Foundation developer certificate.
Alvaro Aspilicueta asks, to retrieve our data of a sensor from the Tangle, how much time can long?
So I think like what's the latency of retrieving a transaction from the network? So with IOTA, once you publish a transaction to the network, it doesn't matter whether it is confirmed or not, that it will be propagated amongst the nodes on the network. So it just needs to be in the correct structure to do that. So if you publish a transaction, you can retrieve it almost immediately back from the node that you sent it to. But if it's another node that you're retrieving it from, it might take a small amount of time. I'd say maybe like a few seconds, depending on the topology of the network, before you can retrieve it back from the node that is somehow connected to the other node.
Cool. One question from Guillermo Perez. He found a node, and he wondered if it's valid for testing with IOTA. Is there a way to tell?
If a node is available and responding to your commands, then sure, you can use it. It's up to the node operator to lock you out of that. But there are a number of nodes that are specifically kind of sanctioned for use in development, and we have those listed as resources in the Hackster page under, I think, Developer Network and also Developer Faucet. So if you go there, you can look at that and you can find the infrastructure that's run by the foundation, which will be more reliable than maybe some random address that you found on the internet.
Cool. Anybody else have any last minute questions? I think that might be it.
Cool. Great.
Oh, wait, one more from Ambus Mix. Can you name any limitations of the Tangle? Are there any?
One thing that I'd like to kind of highlight at the moment is we don't have the ability to do smart contracts. So a lot of people look at the various distributed ledger technologies and they're like, okay, well, I'm going to choose this one because I can have a contract that's run in a decentralized way. We don't have that yet in IOTA. We're working towards a platform that allows for outsourced computing or distributed computation. But in IOTA, we don't have those smart contracting abilities. But that's not to discourage someone from building on IOTA. I think a lot of the applications that you might want to build can be done without smart contracts. So for example, the smart charging use case, there's a lot of different people building smart contracts for those solutions. But with IOTA, because you're able to do the low value transactions, the risk associated with it is quite low. It might only be less than a cent or something like that. And if the transaction goes sideways, you don't really lose anything. Whereas if you need to execute the contract on another network, you have to pay fees that are much larger than the amount that you would be paying for the energy anyway. So,
any news about trinary coprocessors? Asks Yakim Sarvas.
No. So the foundation itself really only deals with the software, but there's work being done outside of the organization, from what I understand, related to the trinary stuff. And there's also some interesting work being done with FPGAs through the EDF to make sure that you're able to have low-powered devices run these computations quite quickly.
Jeff Bakyoga asks, what catastrophe would make a transaction no longer available?
Catastrophe. If the whole network somehow simultaneously went down, which I find very unlikely, but what's more likely is the fact that users on the network will rely on other nodes to store the information. Whenever you're dealing with the distributed ledger network, if you don't run your own node, you don't have access to the ledger itself. So if you're just using somebody else's public node and they go offline, or if they decide to prune the information from their database, then you won't be able to access that any longer. But the general idea with any of these networks is that you should run your own node and you should access the network through that, because then you have control of the information and you might not be, you have a bit more of a secure way of interacting with the network.
Okay, and one last from Vikas Industry. How large of a file can be sent through MAM?
I think in the current library you can send about 10,000 characters, but ideally any of these networks aren't really meant to be sending data, large amounts of data. They're most likely be used for signaling. So for example, if you wanted to run a data marketplace that you wanted to send, gigabyte files, whether that be like raw video data or something like that, you wouldn't use the Tangle to send that information. You might use direct connections over something like a streaming protocol or something that you might use IOTA to send the kind of URLs for. But anything apart from that, I wouldn't really push data through.
Okay, Jervis, so there's a maximum number of tokens. Is there a maximum number of nodes?
Nope. Because it's permissionless, anyone can join in, anyone can access it, and the bigger the network is, the better it gets in that sense. There's more resilience built in because there are more people operating nodes and interacting with it.
All right.
Cool. All right. I think that's all.
Yes.
Great. All right. Thank you so much for listening to me ramble on for 40 minutes. Yeah, hopefully this was useful and you're able to take this and use the information in the solutions that you submit. And if you have any other questions, I'll definitely be around in the discussion page, as well as some of the people in my team. And also we have a Discord that you can jump on in and have an interaction with us there.
Thank you so much, Lewis. All right, everyone, have a great day or night, depending on where you are.
Thanks.
Okay, bye.
Yeah, bye.